Today's lesson comes from Unit 1.1, Notes number 12. In our previous lesson, we learned about the special angle pairs that are formed when two lines are cut by a transversal. Some of those special angle pair relationships are corresponding angles, same side interior angles, and alternate interior angles. In our lesson today, we're going to see what happens to those special angle pairs when they are formed by parallel lines being cut by a transversal. The definition of parallel lines is that it's two or more coplanar lines that never intersect. And we'll come back to why they need to be coplanar in a few minutes. First of all, the symbol for parallel lines is just a miniature set of parallel lines. So just draw two little lines that don't intersect. So in a diagram, we might see two straight lines being cut by a transversal like this. And we might be told, using that symbol for parallel lines, that line A and line B are parallel. So we might see this. Or we might be told by what we see on the diagram that the lines are parallel. So if you see little arrows on your lines going in that same direction, then we would also know that line A is parallel to line B. Now it could be a single arrow or might be a double arrow like that. And in some cases, the arrows are filled in. It just depends on who's drawing the picture. So what that might look like is like a little solid arrow. It's hard to draw this. So again, that would indicate that those two lines are parallel to one another. Now I mentioned earlier that parallel lines must be coplanar. Now here's the reason why. If you take a look at this figure that I have here, the three-dimensional box, if we take a look at line AB, for example, if I extend that, and we also take a look at line CF right here. So imagine you're looking at say a shoe box or a box of tissues, and you're looking at line AB, one of the top edges of the box, and line CF, like the back edge of the box. If you imagine extending those into lines, they would never intersect. So line AB and line CF, although they never intersect, we can't call them parallel because they're not in the same plane. They're not coplanar. So what we say instead is that line AB and line CF are skew lines. It's S-K-E-W. So they are lines that are non-coplanar that do not intersect. So again, the definition of skew: lines that do not intersect that are non-coplanar. So we can't call them parallel just because they don't intersect. We have to call them skew because they are not in the same plane. If you're working on this in class, or if you're working on this at home, you need a ruler and a protractor for the next part. It says in here that we're given line A parallel to line B. And we want to draw a transversal T so that it intersects both of our two lines. And it just says don't make it so that it's perpendicular. Okay, so take your ruler and draw a straight line that intersects line A and line B. Now, because I'm doing this on the iPad, I don't have a way to make it look absolutely straight. So we'll just draw a line. Not too bad. Call that T. And it intersects both of my two parallel lines. So we're going to label these 8 angles formed with numbers. So I'm going to call this angle 1, angle 2, angle 3, angle 4, and keep going down below, 5, 6, 7, and 8. Now with your protractor, you're going to take and measure each of those 8 angles. So pause the video here, take a few minutes, get the protractor, start measuring those angles, and you can fill in the bottom of your worksheet. So you probably noticed a few things as you're going through and measuring your angles. At each of the points of intersection of the transversal in a line, you really only had to measure one angle. Since we know that the two angles that are adjacent and they form a straight line are supplementary, if I found this first angle to be 50, then I can use subtraction to find the measure of this angle is 130. And then I can use vertical angles to show that angle 2 and angle 4 are congruent, and angle 1 and angle 3 are congruent. And then next, measuring an angle down below, we find the measure of angle 6 to be 50. You can do the same thing to find the remaining 3 angles. So you actually didn't have to use the protractor to measure all 8 angles. So what you should notice in here is that we have some special angle pair relationships forming. You see lots of angles that are congruent to at least one other angle, but I see that I've got 2 sets of angles that are congruent. Like I have 4 angles that have a measure of 130 degrees and 4 angles that have a measure of 50 degrees. Now, I had to estimate my angle measures because I wasn't using a protractor, so your angle measures, of course, are going to be different. So the next question says, what do you notice about some of the pairs of angles? Well, as I mentioned before, you probably noticed that some pairs are congruent. So let's think about our special angle pair names from our previous section and see if those special angle pairs are congruent. So if you take a look at your diagram, would you say that corresponding angles are congruent? You can also say from your diagram that alternate interior angles are congruent. Of course, we know that vertical angles are congruent. And finally, you should notice that same side interior angles are supplementary. Be careful with this last one because we're so used to saying that angles are congruent. Be careful, a lot of people make the mistake of saying same side interior angles are supplementary. They can be, but they don't always have to be. Next, we're going to write the conditional statements for each special pair of angles and the relationship that we've discovered. The one that we'll leave out are vertical angles. That comes from a different section. We know that vertical angles are congruent. That's nothing new for us, and that's not dependent on the lines being parallel. So for each of our conditional statements, we're going to start by stating if 2 parallel lines are cut by a transversal, then we're going to say what the result of that is. So we noticed in our figure that when 2 parallel lines are cut by a transversal, corresponding angles are congruent. So I'm going to add a little diagram to illustrate this. So if these 2 lines are parallel, so let's show that they're parallel by adding the little arrows, and they're cut by a transversal, then we can mark a pair of angles congruent to each other. So I'm just going to mark this angle congruent to this angle. If 2 parallel lines are cut by a transversal, then corresponding angles are congruent. Our second theorem starts off the same way. If 2 parallel lines are cut by a transversal, then alternate interior angles are congruent. Just like we did on our first example, I'm going to illustrate this by showing you a pair of parallel lines. So if we're given that two parallel lines are cut by a transversal, then we're allowed to say that alternate interior angles are congruent. And remember that there are two pairs of alternate interior angles that are formed, so both pairs would be congruent. So we can mark those two congruent as well. Our third theorem starts off the same way. If two parallel lines are cut by a transversal, then same side interior angles are supplementary. Be careful with this one. They're supplementary, not congruent. And again, we can illustrate this by first starting with two parallel lines. So again, we have to have an indication that the lines are parallel, so look for the arrows or look for that in writing. And we are going to say if those two lines are parallel and they're cut by a transversal, we want to say that same side interior angles are supplementary. So I can't mark them so that they're supplementary. Let's number them angles 1 and 2. And we would then be able to conclude that the measure of angle 1 plus the measure of angle 2 equals 180. Or you can say angle 1 is supplementary to angle 2. Alright, our final theorem for today states that if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other also. By the way, the symbol that we can use for perpendicular looks like an upside down capital T. So if you see that symbol, that stands for the word perpendicular. So let's write this in if-then form. If, let's say A is parallel to B, so line A parallel to line B. All right, and let's say that a transversal, and we'll call it C, is perpendicular to A. So line C and line A intersect to form a right angle. Then we can also conclude that C is perpendicular to B. And this can all be shown to be true because if we know those two lines are parallel to each other, then we can say that these two angles are corresponding angles. So they must be congruent. So if this is a right angle down here, that forces this angle formed by line B and line C to also be a right angle.